All right, everyone, please make your way back to your seat. We are going to move into the part of the meeting where we're going to be hearing directly from CRESCENT personnel. So we'll be getting into a little bit of the nitty-gritty of the science that we're all talking about today. So I'd like to begin by handing it over to Diego Melgar, who is the director of CRESCENT, for an introduction to the background of this organization.
Thank you, everybody, for coming. For those of you who don't know me, my name is Diego Melgar. I have the privilege of serving as the director of CRESCENT. And in that capacity, the first thing I'm going to do is I'm going to go off script, Valerie and Andy. I want to just share something with you very briefly. When you train to be a scientist, traditional Western science tells you when you're a graduate student that the most valuable thing you can do is basic research. That learning about something from first principles, about knowledge for knowledge's sake, is the most valuable thing that you can engage in. That societal motivation for research is something that is not as important, or not necessarily the reason why you should carry out a specific research agenda. Now, the world is quite literally on fire. And so there are increasingly large numbers of us who reject that view and that think that societal import is a perfectly valid reason for engaging in a specific line of inquiry and of questioning. And so this meeting is born out of that notion. And I don't know of anybody that embodies that ethos of being a scientist better than Professor Valerie Sahakian, who put this meeting together. This is her vision. This is her brainchild. And so I'd like to ask you, Valerie, to stand up. And I'd like to ask each and every one of you to help me in thanking Valerie for putting her... Sorry. We are now 1 minute behind schedule. Okay, so why are we here? This is why we're here. This is what we are hoping to deliver to the likes of you in this room. Models of shaking and of tsunamis like the ones you see here in the left. This is from Valerie's group, and this is from my group. It's really hard to put those animations together. The amount of knowledge and research that goes into that simple animation spans decades of work by sometimes hundreds of people. And we haven't always been as connected as we could. So CRESCENT is an effort to bring everybody together so that when we give you these kinds of models and animations, you can be assured that this is the collective decision and brain power that has come together to tell you this is our best guess, educated guess at what we think is possible in the Pacific Northwest. The center, as you might have heard before, and I'm sorry if this is a little bit repetitive for some of you, is a new, we're in the 2/3 way through year one, cooperative agreement between the University of Oregon and the National Science Foundation. We have 6 center staff that are here who have been thanked as well this morning. Our senior personnel cover about 13 to 14 universities and include well over 50 researchers at this point. You've heard before that we have 3 objectives or pillars. The first one is the science behind earthquakes and why the hazards are what they are. We also have a geoscience education and inclusion pillar that you'll hear about in a second, which is about expanding access to careers in the geosciences. And finally, we have the partnerships and applications pillar, which is why we're here, which is about connecting the science to meaningful societally relevant outcomes. We're distributed nationally. Obviously, the locus of the researchers is the Pacific Northwest, because that's where the issue is, in Northern California as well. But we have researchers from all over the country because the problem is fundamentally interesting. So it's drawn attention from the nation's intelligentsia, if you want to think about it that way. And so we have direct funding for graduate students and postdocs and faculty. They receive money through the center to engage in research about asking and answering these questions about earthquake hazards. Also to undergraduates and graduate students and seed grants to PIs that were not involved in the original writing of the proposal. We're trying to make the circle as broad as possible so that we can make headway on this really thorny and complex issue, as you've heard this morning. I'm going to tell you a little bit, and then you'll hear more about the research. It's divided into 5 main working groups, and I'll tell you about them in a single slide. I'll be super fast. And we have 4 on the periphery special interest groups, which we consider as proto-working groups. They are the things we really would have liked to fund, but the budgetary reality set in, and so we couldn't fund everything we wanted to do. So we prioritized more funds for the working groups and just a little bit of support to the special interest groups to keep the candle lit for CRESCENT version 2. Each working group is people. It's cyber infrastructure and software and computer developers and hardware and all of that, but it's really people. And a lot of those people are in this room today. They lead the working groups and they collaborate with others within the working groups. So could people, scientists and students and grad students that are involved in CRESCENT, could you just stand up if you're involved in any meaningful way, just so, I see you, Ben, stand up. Thank you. So shake their hand if you see them later. Okay, so what you're going to hear about is the specific science agenda, and the first working group is what we call the community velocity model. And what this group is trying to do is come up with the best three-dimensional view of what's under our feet. That's surprisingly challenging and fundamentally important to make that animation of what shaking is going to be. The seismic waves travel through different kinds of rock with different shapes, and if we don't know what those rocks are, we will never be able to make adequate simulations of what's expected in a big earthquake. So you'll hear about them. The community fault model is trying to put together a catalog of every fault in the Pacific Northwest that we think can be hazardous. And so this is, in these red lines that you see on the map, this is from the USGS Quaternary Faults database. We want to know where all the faults are and how hazardous we think they are. That's really challenging, but as you've heard this morning, a fundamental input into any kind of probabilistic assessment of the shaking hazard and of the tsunami hazard itself. It's not just about the megathrust, it also mattered the crustal faults like the Seattle fault, the Portland fault, the Whidbey Island fault, etc. They are equally important and not always well constrained. The DET, Dynamic Ruptures, Earthquakes, and Tsunamis group is trying to put together what is the math, physics, and computer science behind actually making these simulations in the best state-of-the-art way possible. That is very much an evolving field because the technology, the hardware, and also the modeling techniques are changing quite literally week by week. So what do we need to leverage from those to answer questions about Cascadia? The Coupling, Slow Slip, and Seismicity group, C3S, has the modest task of finding all the earthquakes past and present in the Cascadia subduction zone to understand which faults are locked and which faults are hazardous. And we're trying to do this by leveraging modern machine learning and AI workflows in order to discover all this data. And how do we use this information for long-term planning, and how do we insert that into hazard maps? That's something that we have to find out with many of you in this room. And finally, but not least importantly, is the Cascadia Paleoseismology group. They're conducting significant amounts of fieldwork starting, I think, next week. This is year 2 of fieldwork to establish chronologies of past ruptures in Cascadia. So they look for evidence of coastal subsidence and tsunamis from past events to try to say when and how frequently and how big were past events in the subduction zone. You can't know the future without knowing the past. And so what we're looking for is your feedback. So this research agenda was designed by academics because we thought we knew what the research gaps were, and so we put together those working groups. But we want to know if there's something that we missed, or if there's a way in which we need to adjust and point the research ship in a direction that is more meaningful or immediately useful to all of you. We call that bidirectional communication, and we use that term very freely in the proposal, but what does bidirectional communication actually mean? We're finding that out here today with all of you. And beyond that research agenda, I just want to run you very briefly through a few other ways in which you can try to engage with the center. We are having a yearly, more science-focused meeting, the CRESCENT meeting. We already had the first one in October back at the University of Oregon. Here are all the happy attendees. Jay, I think you're wearing the same shirt there. And so this will be a yearly, hopefully, occurrence. So please stay tuned if you want to engage more deeply with the science aspects of this. The seed grants are very important, and this is a program that's co-funded with PG&E, and they're short, very streamlined submissions. This year, we already funded 14 seed grants, and what I want to convey to you is that we would have loved to fund more seed grants in the partnerships and application space. We just did not get the submissions. I think it's because maybe people thought we were only going to fund science proposals, but that couldn't be further from the truth. If you have a partnerships and applications idea, write us a seed grant, and your odds of success are fairly good. So please go ahead and think about that. The RFP should come out November, December of this year for the second iteration of that. We also want you to think of CRESCENT as a town hall. We want it to be a space where we do this, what we're doing here today, not just between those of you already working in the earthquake resilience space, but also between all these different science efforts that were alluded to in the morning, like SCEC, the COPES Hub, and SD4D, other science efforts. It's a confusing landscape out there sometimes. And so we want to have a central location, which hopefully could be CRESCENT, where we can all come together and talk about these issues. And I think Andrew's going to tell you a little bit about the geoscience education and inclusion opportunities at CRESCENT.
All right. Hi, everybody. I'm Andrew Meggs from Oregon State University, and I'm the committee chairman for the Geoscience Education and Inclusion Pillar. And the CRESCENT personnel who are in charge of this is Shannon Fasola, who's sitting in the back right-hand corner over there. She's our program manager. The pillar was conceptualized around a well-known problem, and that is that earth science struggles with both its perception, its visibility, and its relevance to underrepresented communities. And we viewed that as essentially an opportunity because of the fact that many of our subdisciplines in the broader field of earthquake science are challenged to attract new people to those professions. And thus, we assigned ourselves a mandate, but it was also part of the RFP to help train and mentor a diverse future workforce. And to do that, we developed a system or a series of opportunities that engage people across all career stages. And those career stages are, I don't know if high school is a career stage or just a time we all try to struggle and make it through in one piece. But we have these 5 opportunities out there that begin with the high school STEM program, in which we're trying to engage people, particularly from underrepresented and indigenous communities, with earthquake science by going to them and then encouraging them to come to our universities to see what it would be like to be a college student working in earthquake science. We have an undergraduate twinning program, which is think of it as an internship program, although it lasts for a year long, and it is a fully funded initiative in which a student works with mentors at 2 different institutions, and the goal there is to expose students to different cultures in science. And as Diego said, with respect to the seed grants, this is another opportunity where we feel that getting projects from partners that are actually outside of academia helps to achieve our goal of building a workforce for the future. So our announcement for that, I think, will go out also next year at some point, and hopefully we'll solicit more projects that involve partnerships between people outside of academia and academia. Then the Course to Code summer school is a field course that will introduce students to both the data collection and data analysis process that goes on in earthquake science, and it's intended to introduce people to paleoseismology as well as the other applications of those data in earthquake science. We are trying to create opportunities for graduate students and other early career people to have professional training. And this fellowship is funding, I think, 5 people this year to go to different meetings that are about education, pedagogy, and have ample opportunities to learn about career development. And then finally, the center itself will be hosting technical short courses, which are intended for professionals or people in working groups to explore specific topics in science. And I would just highlight the Course to Code program at this moment because this summer field school will take place at Cal Poly Humboldt, which is a minority-serving institution and seeks to attract underrepresented students from that university as well as others around the country to learn paleoseismology and modeling techniques as a way to hopefully fill the gaps that exist in the professional workforce. Paleoseismology is a good example in so much as I think about half of the active U.S. coastal paleoseismologists are in this picture, and that means there aren't that many. All right, and I think Valerie's standing up, so that must mean I'm done. But if you have any questions about any of these programs, either Shannon or I are available here and via email.
And then really briefly about the last pillar of the center, which is this partnerships and applications pillar that you've been hearing about and Diego sort of mentioned. The idea with this is we're hoping that we can build relationships between the center and all of you and various communities and stakeholders that are interested in and affected by the hazards. So hoping that the science in the center doesn't just stay in the center and is useful, but also that we're directing what we're doing towards what the societal needs are. And so there are a few ways that we're hoping to do that, or at least planned ways. The first is this partners meeting today, and that's one bullet point, but really we're hoping that this is something that grows into something bigger. So whether you are collaborating with the working groups or it's just a constant line of communication, we're hoping that that's achieved through this. We have CLIP webinars, so the Cascadia Lifelines program, which is run out of Oregon State University by Michael Olson back there. If you could raise your hand. This webinar series is mostly designed for practicing engineers, and it's focused around mostly seismic-related resilience in Cascadia. So I think we've had 9 webinars already? We've had a handful of webinars already through this. We also have a newsletter that comes out quarterly called the Seismic Moment that you can sign up for. So there's a QR code there on the left, and it's also on the papers on your table if you're interested. And then lastly, related to this, there's also coordination. And so we're hoping to learn more about what you all think that should look like, mostly in the second breakout, but predominantly this afternoon. And then the last thing, which I'll remind you all at the closing, is that we have a tentative date for the same workshop next year, which is around the same time as June 26th to 27th, 2025. And so with that, we're going to have 2-minute lightning talks from the CRESCENT working groups and special interest groups. And the first is going to be the community fault model from Ashley Streig.
Okay, 2 minutes. I wanted to do 10 slides, but I got 1. I'm pretty sure I could have still done it. So I'm here representing our community fault model group. Our goal, I'll stay by the microphone. Our goal is to generate a 3D representation of faults that are capable of generating an earthquake in the Cascadia region. We have a pretty large group. There's 8 of us working in this group, 9 now. We've actually just hired our postdoc, so very exciting. She'll be coming online in September. About half of our group is here, so community fault model folks, you want to stand up? That's probably the easiest. So if you have any questions about what we're doing, feel free to chat with any of us when we're in the breakouts or at any other time today. I'm just going to go through some of the main points here. So I've mentioned our goal is a 2D and 3D representation of seismogenic faults. We imagine that this will become something that's useful for a lot of different purposes, and some of you are probably already thinking about that. Seismic hazard assessment is an obvious one, so some people have talked about that today as they talked about PSHA, or probabilistic seismic hazard analysis. Knowledge of stress accumulation on faults, so that's something that's going to be coming online a little bit later. That will be point data on paleoseismic information that we have on upper plate faults. And then the 3D representation really is the big thing that we're working on right now. So we have a version 0.1 that some of you may have seen, and our web viewer should be coming online in the next couple of months and up for review in the fall. So that 3D representation is kind of stemming off of what we know from the USGS National Seismic Hazard Model. So we're using their 3D representation, and then we're going to move from that kind of coarser model, nationwide model, to something a little more refined and including new data sources for this region. This is something that we talk about a lot, what our priorities are for data inclusion. We have some partners in the room that we've been chatting with that we view as a resource for both ourselves and our postdoc, and we have planned every year that we'll have kind of state of the CFM that will be remote in the years when we aren't meeting in person. And they will be, in our biannual meetings, we'll have a breakout where we can talk about the CFM, we'll release it in advance, and we'll have an opportunity to gain feedback from the community as you review those things. That's my cue. Thank you.
Hey everyone, I'm Peter Scher. I'm an assistant professor in geophysics at Oregon State University. And it's great to be preceded by the CFM group because as you saw in those models, you have these planes of weakness along which slip occurs. But in between those planes of weakness, in between those faults, isn't just nothing, isn't a vacuum. There's rock. And actually that rock isn't uniform. It is highly heterogeneous. And so it is the task of the CVM team, the Community Velocity Model team, to build a multi-scale comprehensive model of material properties in the Cascadia region for a volume that actually extends well beyond Cascadia and from the surface up to almost 100 kilometers depth. So this is a big task, and I'm fortunate to be part of a wonderful and ever-growing team that is working on this very important task within CRESCENT. And the reason for building this model is you've heard about this a lot today already, but one of the things we need this model for is for ground motion earthquake simulations. If you don't know what the rocks are made of, you don't know how the ground's going to shake beneath our feet over here, in the Cascades, in the Coast Ranges. Those places are all different in terms of what's beneath our feet. Other things that are more interesting for us nerds out there, subduction zone processes, what is the stress buildup within the Earth? Once again, you've got tectonic forces. What the strain and stresses are that correspond to those forces is a function of material properties, as they are for the faults that are within the Earth. We're going to do this in a multi-scale type fashion. I welcome you to go to poster number 2. I'll be there to answer your questions. And kind of it's all the way from a 10 kilometer to 100 kilometer to 1 meter type scale that we'll be covering within the CVM team. And I'll leave it at that for now because I think my time is just about up. But please come to poster 2 if you have more questions. I'm happy to answer them. Thanks so much for your time.
So cute. All right, my name is Tina Dura. I'm an assistant professor at Virginia Tech, and I'm the lead of the Cascadia Paleoseismology working group. And our objectives are to reveal the patterns, timing, and size of past earthquakes and tsunamis to better inform earthquake models and to really start to build a more integrated relationship with modelers so we can kind of supply these data sets to modelers for validation and also learn from the modelers where they need more data. So to do that, we're going to conduct new field work along the Northern California, Oregon, and Washington coasts. So a lot of the paleoseismic sites that have already been visited, we're going to revisit and conduct more high-resolution analysis with kind of more updated quantitative techniques. And so one example here is at the Salmon River, where you can see the existing cores that had been taken before without an outline on them, the new cores that we've filled in with new field work, and basically better defining the inland extent of tsunami inundation, going beyond the limit of sand deposition, and also using more updated quantitative techniques to quantify subsidence, which is another hazard that's going to come along with the earthquake. And also to kind of focus not only on 1700, but over multiple earthquake cycles that can go back thousands of years to really understand is 1700 representative of what can happen, or could we even expect even larger earthquakes? So our products, we're working closely with USGS. So one thing is the new quantitative estimates of tsunamis and subsidence. We're going to create an online database of these geologic observations, so a modeler could go and get that data and then use it to validate their models. So that'll be available. And then we're also developing a shared community-built diatom and foraminifera database. Those are microfossils that we use that are in the sediment and the stratigraphic record that can be used to get these quantitative estimates of subsidence. And if you have questions about that, I can tell you more about it. But the hope will be that more people can apply these methods and we'll have more and more of these observations. Oh, cool, birds. All right, thanks. Hi, everyone. My name is Amanda Thomas. I'm a faculty member at the University of Oregon, and I'm here today representing the C3S group, which is coupling seismicity and slow slip. And so this is a working group that consists of a number of sort of observational seismologists and geodesists. And basically our charge is to characterize all strain accumulation and release, all mechanisms of strain accumulation and release in the Cascadia subduction zone. And so we're interested in developing sort of 3 fundamental products. The first one is the block and coupling model. And so this is a model that basically takes in the faults that are going to be produced by the community fault model and estimates the strain that's being accumulated along those faults, where basically the idea is that that will give you an estimate of the earthquake potential of those faults in the future. The second product that we're trying to generate is a seismogeodetic detection framework. And so our idea here is to basically take in and assimilate both seismic and geodetic data to almost in real time characterize different sources of deformation in the Cascadia subduction zone. So these could be things like earthquakes or tectonic deformations, things like slow slip events, but also things like hydrologic signals, volcanic deformation, and sources of anthropogenic noise. And so the idea is that if we can better characterize all the different sorts of sources, then we can sort of hone in on the tectonic component and better understand hazard in that way. The final piece of this, and the one that I'm most familiar with, is using things like artificial intelligence and machine learning to assemble sort of a state-of-the-art seismicity catalog. And the idea is that we will use this to sort of better constrain, we'll work with the community fault model group to better constrain fault geometries, and just general the seismic potential of the different faults in the Cascadia subduction zone. The other thing I wanted to mention that's not related to C3S is I run cyber infrastructure for CRESCENT, and so it is my charge to make sure that our products are transparently produced and that they're disseminated to people interested in using them, aka you, in accessible formats. So if you have any feedback on that front, I'm all ears, and you can find me in the back. Thank you.
Okay, so the DET group, or Dynamic Rupture, Earthquake Cycle, and Tsunamis group, couldn't be here today, so I'm presenting for them. But their working group is looking at dynamic ruptures, which are models of earthquakes that are seeded essentially from our knowledge of what the stress conditions are on the fault. So we take information about where the plates are stuck and where they aren't to try and figure out where the earthquake will start and what part of the fault that it will break. And so the things that they will be producing are single event dynamic rupture, so one earthquake that is made from these conditions, but they're also looking at earthquake cycle models, so models that have many earthquakes that span thousands of years to try and capture when and where earthquakes occur, how frequently, how big. And will also take into account other types of tectonic motion. From that first set of earthquakes, the single event dynamic ruptures, they're also going to try and understand what does that mean for tsunami generation for each of those earthquakes. So looking at what seafloor deformation is and what tsunami run-up might be. They're also focused on community code verification, so thinking about benchmarks for all of these codes they're producing for these products. So they're going to produce open source software and a web platform for the code comparison. But lastly, one of the things that they're producing with these earthquake models are low frequency estimates of shaking. So because these are really computationally intense models, at the moment, it's a little bit too expensive to produce ground motions, high frequency ground motions for engineering purposes from all of these models. But that's where the next special interest group comes in that I'm about to talk to you about. So transitioning to that, the special interest groups, as Diego mentioned, are sort of proto-working groups. So they're working groups for which we either didn't have enough funding yet, where we think we want to define directions for the future, or even things that maybe need existing CRESCENT products in order to move forward. And I think these are, first, a great opportunity for collaboration, so hopefully something that we all discuss today in the breakout groups. But second, I think this relates to the first special interest group, which is the Frontiers in Ground Motion Modeling Special Interest Group. At the moment, this is myself, Alex Grant, and Aaron Worth, if you could stand up. So you know who those folks are. And what we are hoping to do is think about the ground motions, these being the hazard to people in the built environment. There are a lot of factors that control how strong and how long shaking will be, including things like the regional geology, which is why we need an improved community velocity model to do a better job at this. And there's a lot that we still need to understand to improve estimates of shaking. And so our goals and the directions we're hoping to go in is seeking to advance our models and estimates of shaking. This is using tried and true methods, a lot of empirical ground motion modeling tools, as well as some cutting edge tools. So thinking about how can we incorporate those earthquake models from the DET group into this. We're also hoping to integrate information that's coming out of the different working groups, so out of CVM and DET, but also the community fault model, so what are the fault sources coming out of that. And we would really love to learn about what your needs are so we can think about co-designing research agendas and figure out in what directions should we be focusing on with this particular group. I think Ben is up next. Yeah.
Thank you, Doc. All right. Cool. So at this point, I suspect that most people are aware that earthquakes drive a lot of ground failure, right? And so that affects a lot of things, including recovery, emergency response, bouncing back from the big one. So the objectives of this group are to look backwards and forwards to basically have a more resilient response. From the past, there's been a lot of cool work done on shaking proxies, past landslides, liquefaction, all these things, basically trying to constrain the intensity and the effects of an earthquake. This is useful because it helps us contextualize what those impacts might be if the big one happened today, so the present. There's a lot of cool science products that have been described today, and a lot of those can be very much applied to basically looking at what ground failure might look like if the big one was to happen, whether that's liquefaction and its effects in urban areas, whether it's landslides and the effects on lifelines, all these things. Our goal is to develop some tools for planners, that's you, engineers, scientists, those who are dealing with our infrastructure and our communities to better help emergency planning and resiliency. Then, of course, there's the future. When you have an earthquake, you're not out of the woods. There's hazards that linger for quite a period of time, and there's big questions about how we respond to that. Do we build it back immediately as to what it was before, or do we build it in stages? How do we respond to this? So one long-term goal is looking at best practices for recovery, particularly as it relates to landslides, liquefaction, lateral spreading. And the big part of this is it requires collaboration with planners, people who deal with the real world planning of how we respond to these earthquakes that we've talked about today. So that's what I got. Thank you.
So I'm William Wilcock. I'm from the University of Washington, and I'm here for the Offshore Observation Special Interest Group. And to a pretty good approximation, part of the fault that will rupture during the Lakes Great Earthquake will extend from the coastline to the base of the continental slope. So it's sort of pretty obvious that to understand that, you want to make observations offshore. And those can be the deployment of autonomous or cabled or buoyed geophysical sensors to monitor. They can be imaging experiments of the subsurface, or they can be detailed mapping and geological sampling. And all those kinds of observations are really germane to what the CRESCENT working groups are trying to do. And we heard this morning about efforts by NOAA to improve the timescales for providing tsunami warning, means putting sensors close to the shore. And on a longer time scale that probably exceeds my time scale, we will at some point have earthquake early warning systems everywhere off the shore, and they can use a combination of specialized infrastructure and take advantage of telecommunications cables. Really exciting technologies coming along. And so all that's really important. Offshore scientists like me can proceed sort of in the old kind of science that Diego doesn't like without really worrying about this. But I think having an effort within CRESCENT can do a lot. On the short term, it can help us coordinate the science we're doing. And on the longer term, it can help us plan. And we do need the community. We're going to invest tens, hundreds of millions in offshore warning systems. That's going to need society saying they really want that, not just scientists. And so in terms of what the Offshore Observations Group does, we just have one thing funded in CRESCENT, and that's going to be a meeting next year where we can bring together the community. So we're going to basically try and build an email list, get some input from people, form an organizing committee, and meet probably about this time next year. So in a couple of years' time, hopefully I can come here and say something more concrete about what we're doing going forward, because we're really still in the planning stage.
Okay, it's me again. So the final SIG of CRESCENT is a Cascadia or community fluids model that we're trying to build. And despite what you've read, these fluids are not a model of above and below ground breweries and wineries in the Pacific Northwest. You can go to Google for that. No, there are other types of fluids around. The one that's really familiar to us is meteoric fluids, so precipitation. This is an area with a huge amount of precipitation. And so those fluids affect the very near surface. And those type of fluids will be taken into account in this model we're trying to build. But there are deeper fluids inside the Earth as well. And these result from mechanical and chemical processes inside the Earth, several tens of kilometers down. And those are important for earthquake triggering. They play a role in the fact that we have volcanoes in the Cascades. So these things lead to flux melting inside the lithosphere, and that's why we have magma and volcanic eruptions. And then near the surface, these fluids, as I mentioned, are important for landslides and liquefaction. For those things to be hazardous, you need a lot of water. So over the span of these 5 years, we're going to start a conversation on how to build a comprehensive fluids model for the Cascadia region. There are several people involved. Some of them are listed at the bottom, but the group we hope will be growing over time. And we want to try and use any geologic, geochemical, geophysical data that we can get our hands on to put together this model of fluids for this region. And we hope in future, as Diego mentioned earlier on, that this will lead to a full-fledged working group that can make progress on this very important scientific and societal front in the Cascadia region. And with that, I am done. Thank you.
All right, so we will now have a little bit of more time for Q&A, but I want to begin by giving Tiffany Brown from OSSPAC an opportunity to give us an update and some of the details on the Oregon Resilience Plan, and specifically how that relates to what is going on here at CRESCENT.
Thank you so much. Thank you for carving out some time. Good afternoon. My name is Tiffany Brown, and I am the chair of the Oregon Seismic Safety Policy Advisory Commission. Some of you may know me by my day job. I am a county emergency manager and have been on the Oregon coast, Clatsop County, for the last 13 years. I've worked with a lot of you. If you missed the memo, I switched teams, and I'm now in Lane County with Crescent and Shake Alert and nestled back in the Willamette Valley. So thank you for giving me a few minutes to talk today about OSSPAC and more specifically the Oregon Resilience Plan. You may alluded to it earlier this morning. It was drafted in 2013, and it has been the seminal document in Oregon for guidance around how we become more resilient against this big threat that we're talking so much about today. In 2023, I was approached by the, at the time, state resilience officer who suggested that we do a 10-year review of the Oregon Resilience Plan. And indeed, a lot of people felt that it was time to circle back and kind of look at what we'd done. A lot of things have happened in the last 2 years, and so it's been fits and starts. We can't call it the 10-year review anymore. But we are in the process of diving in to develop a document that reviews and reflects on that seminal document that we created in 2013. Kent, you led about 150 professionals in that effort, and the value of that can't be estimated. We think that the review document will be a much less of a lift. In a large part, it will largely revisit the chapters and the recommendations and do an assessment and sort of look at what worked and what didn't. We've talked about the original recommendations. No one, not the current OSSPAC members, not the ORP forefathers that we've brought in to sort of talk about the project, believe that there are really any new recommendations under the sun necessarily. It's really about just performing an analysis. There will be a change to the new document. We know now what we probably knew in 2013, but we were largely focused on infrastructure with that effort. There will be a new chapter in the review document entitled Social and Community Resilience. We understood, and it was very important to look at infrastructure and our physical environment, but we know now better than ever that preparing our communities and preparing at a broader level and preparing individually is also a key piece of that. How can you help? We're getting, I'd like to take a minute and put Allison on the spot, my co-chair. A lot of you probably recognize her, Allison Perch. We had a strategy for moving forward with work groups, and it didn't work out as designed. And so a couple weeks ago, Allison and I got together and we split up the chapters, and we're going to start tackling those. We're looking for people to assist us with reviewing those chapters, formatting them, coming up with ideas about great examples, best practices that we've seen in the last 10 years. If you don't want to be part of a work group, we're looking for just folks to help us with looking and reviewing the plan and giving some feedback as we go through the draft documents. And we're standing up a page on the Oregon Emergency Management website that explains more about the project. It's not there yet, but we've completed a survey for the community. And so if all those other things sound like too much work, please take a minute to participate in the survey and give us some feedback about how we can proceed through the project with intention and produce something that's useful to everyone. I hope to get the email addresses when this is over and contact you directly with recapping some of what I said here and inviting you to contact us and get involved in this project. Just a note before I'm done, with my county emergency management hat on, I was in Clatsop County for 13 years, ground zero, highest hazard county on the coast for Cascadia. And this work was really hard when I started in 2011. It was hard to have the conversations, and it is this work that we're talking about in the room today. Yes, it's for the physical environment, but the work that you do and the work that you have brought forth to local communities gives people like me the ability to have the conversation. In 2011, it was too big and overwhelming, but when we're able to talk about island mapping and modeling and improvements to the physical environment, it helps me have the conversations and start getting at that community and social resilience piece. So thank you for your time. Thank you for giving me a few minutes, and have a great day.
Thank you so much, Tiffany. We're going to start with one question directed towards the CRESCENT presenters, and then we will go back to a couple of the questions that we weren't able to get to in the morning. So the first question is for Tina. And the question is, how do you integrate traditional knowledge, storytelling, and other indigenous cultural records into your work?
Hi, sorry for screaming into the microphone. We value this knowledge. We have not integrated it as much as we could, and I'm interested in learning more about how we could do that.
Awesome. Thank you, Tina. And then a question for Diego. So does CRESCENT plan to develop long-term earthquake and tsunami event sets based on the underlying hazard rate models?
If you think that's valuable, you need to tell us, and then we will try to make it so by leveraging not just what the DET group is doing, but there's other efforts like the M9 effort that finished already. That's an event set that's widely used in the engineering community. Whatever COPES Hub is putting together, that's an event set that I'm sure will be used widely by the community. So if you think that that continues to be of value, then we need to know so that as DET continues their work, we can deliver it to you in formats that are useful with ground motions, inundation models, and so on. So yes, if you value it.
Awesome. Thank you. So moving back to some of the presentations from the morning, I'd like to start with the Shake Alert folks. So that's Mike Brzezinski, Gabrielle Lotto, and Bob DeGroot. So a couple of people had some questions related to the frequency of alerts that come through on the apps and on the phones. So one person was asking about the potential impacts of over alerting and whether that could have an impact on the uninstall rate. And then similarly, someone was asking about, since there have not been any shake alerts in the Cascadia region specifically, how that might impact these kinds of surveys and studies of the effectiveness of shake alert.
I'll work on the first question first and think some more about the second one. But I have some details on the rate at which alerts are going out via the San Diego County app on the poster. But a quick summary is the mean time between alerts is 5 days. So it gives you an idea of just how frequent alerting is when we're talking about multi-hazard. So over 50% of the alerts are fire related. Those come during particular seasons when fire is of higher risk in those communities. So it's not every 5 days, obviously, right? But certain times of the year where it's many events, many alerts are going out in a given day. graph that we have on the poster shows that, yeah, when you get to days when there are on the order of like 10 or more alerts, yes, we see a slight increase in the uninstall rates on those days, but it's far outpaced by the install rates. Install rates jump over an order of magnitude on those days with only a modest increase in the uninstall. So again, that's part of the reasoning why we're arguing that the over alerting is not as big of an issue as we might think. And in fact, even just look at lower alerting rates, if the number of alerts per day increase, the install rates are really kind of ramping up, and the uninstall rates are pretty flat. So again, just some indications that people want information, and so alerting is one of the ways that they get information. The second part of the question in terms of differences we might expect up here in Cascadia, given the limited number of alerts. So there's some guidance comes from and Bostrom's work that when asking people about sort of their experiences with earthquake hazards, that gives some clues that people are cognizant of this hazard and want to know some more about it. But yes, that particular survey didn't really sort of focus on alerting and warning. And so that's part of what we're hoping to do with the seed grant, is to get more at those questions about what are people's expectations for warning, what are their sort of thresholds, what do folks want to receive in terms of alerting, how do they want to receive them, what kinds of impacts can we have in terms of preparedness via alerting, right? In some of the data we've seen from San Diego County, again, on the other poster that's a little bit more survey focused, when we ask people about their response, when they first feel shaking, what do they do? 0% of the people thus far have said drop cover and hold on. Okay, mostly they're frozen. They mostly put stay where they're doing, stop what they're doing and stay put. But then when we ask them what's their response when they get an alert, we get about half the people responding in ways that are appropriate. Drop cover, hold on. Some flee buildings, we talked a little bit earlier, that might be the right response depending on what building they're in. But again, alerting is having an impact on people's actions in response to earthquakes. So again, I think this is part of where we'd like to head with alerting, both in terms of surveying as well as sort of trying to develop the alerting systems, is to start changing behavior, right? It isn't just about sort of promoting in different ways that we do, which I've heard some great things about today. Even in the moment that it's happening, there are opportunities for outreach and education at those moments. So taking advantage of those, I think, could help.
Thank you so much. Another question for Diego, specifically about those seed grants. So the question is, who is eligible to apply for those research grants, and how are they evaluated and selected for funding?
Anybody, if you are eligible for federal funding, you're eligible for a seed grant. So that's it. That's the only requirement. They're evaluated by a panel. This year, there was a panel of about 10 to 12 people, scientists, engineers, a panel of people not involved in the senior personnel of CRESCENT. They have a rubric. They make a recommendation. And then the executive committee of CRESCENT looks at the recommendations and decides on funding by looking at things like balancing the portfolio so that we're not funding 7 CVM grants, so that we keep it fairly homogeneous in terms of some GEI grants, some P&A grants, some CFM grants, and so on. I have a newfound appreciation for NSF program managers.
Awesome. Thank you. And I've got time for one more question directed to Valerie. So the question is, how does the work, I think specifically with the DET working group, how does this work build upon the M9 project? And what are the refinements to the science that these modern seismicity workflows incorporate?
Right. So these models are different from the M9 project, in that the M9 project models are generated in a sort of stochastic, or not random, but somewhat random sense, in terms of we prescribe what part of the fault we think is going to break and how much. The DET models are taking it a step sort of back from that, and they're saying, based on what we know from GPS and what parts of the fault we think are locked and stuck together, what parts of the fault are most likely to generate the first part of the earthquake, so to start the earthquake, and then where is that earthquake going to travel, and what parts of the fault will it break. So the idea is that it's based in the physics of how how the tectonic plates are locked.